Electrolysis, electrolyte is in aqueous solution, or electrolyte is an aqueous solution. Deduce the products formed during the electrolysis of an aqueous solution of potassium fluoride. Write an equation for the reaction at the anode and explain your reasoning. As the electrolysis involves aqueous solutions, it is possible that water could also be either oxidized at the anode or reduced at the cathode. So always reduction happens at the cathode and oxidation at the anode. Note, it is sensible to show awareness that concentration could affect the discharge at the anode, but without information on this, it is correct to expect the outcome based on standard electrode potential values. So, identify the ions present. So we have potassium ion and fluoride ion, aqueous, both in solution. So we have water molecules. At the anode, possible oxidation reactions are, so 2 fluoride ion give fluorine gas plus 2 electrons, and this is oxidation. Also the oxidation of water, it will give 4 protons, 4H plus aqueous plus oxygen gas at the anode plus 4 electrons. Let's compare the standard electrode potential of both. Which is higher? The higher is water because it's negative 1.23, while fluoride 2.87, negative 2.87. So water value is higher. So it's more preferably to be oxidized. And this is what will happen at the anode. Water will be oxidized, not the fluoride. And oxygen will be discharged at the anode, and H+. At the cathode, possible reduction reactions are, we have potassium plus, it will be reduced, and we have water molecule also will be reduced. So, to compare the numbers, we will find that the water molecule against standard electrode potential of it's higher than the value of potassium. So it's preferentially to be reduced rather than the potassium. And it will give hydroxide ion and hydrogen gas at the cathode. So the products will be oxygen at the anode and hydrogen gas at the cathode. Next, describe fully all the changes you would expect to see during the electrolysis of copper 2 chloride using carbon electrodes. So here, look, carbon electrodes. Write equation to support your predicted observation. And how would you answer to question A if copper electrodes were used instead? So instead of carbon electrode, in question B, we will use copper electrode. What will happen? Let's see that. First, different reactions occur for the electrolysis of copper 2 chloride depending on the electrodes used. For carbon electrodes, so ion present, we have copper ions and chloride ions. At the anode, possible reactions, oxidation of chloride can happen and oxidation of water can happen. The values of the standard electrode potential of both, negative 1.36, negative 1.23. So water is higher. So the oxidation of water will be preferred because standard electrode potential of it is higher. And this is the case when chloride ion is low, chloride ion concentration is low, because the standard electrode potential of both are very close to each other. The difference is not that big. So depend on the concentration of chloride ion. If the concentration of chloride ion is very low, so in that case water only will be oxidized. But at high concentration of chloride, the oxidation of chloride becomes more likely given the greater number of chloride ions that will be found closer to the surface of the electrode. At the cathode, possible reduction reactions are copper plus 2 electrons to give copper metal, and of course the standard electropotential of copper is higher than standard electropotential of reduction of water, so only copper will be reduced at the cathode. So reactions that occur with low copper chloride concentration at the cathode, we said copper will be reduced, but at the anode only oxidation of water will happen to give oxygen gas and 4H plus at the anode. What the observations? Carbon cathode will change to a pink brown color as copper is deposited on it. So at the cathode, copper metal will be deposited on the cathode, which is carbon electrode. So it will give pink color because the copper is pink in color. And the color of the solution will fade. So copper chloride solution is blue, but when copper ion will be reduced into copper metal, so this blue color start to disappear, and bubbles will be observed forming at the anode due to the discharge of oxygen. As you can see here at the anode, oxygen gas will be bubbled. So this is the observations. Cathode color will be pinky and bubbling of oxygen at the anode, and the solution color will start to disappear, the blue color. But if we have high concentration of copper chloride, so reduction at cathode, it will be the same, but oxidation at anode, it's not oxidation of water, but will be oxidation of chloride to give chlorine gas. So the observation will be the same, but bubbling of chlorine gas. Here bubbles will be observed forming at the anode due to the discharge of chlorine gas, and the green gas, the chlorine gas is green, will be observed leaving the solution. So the observation exactly the same, except that chlorine gas, which is green in color, will be bubbled instead of oxygen gas at the anode. Now if we replace the carbon electrode with copper electrodes, so ion presence, we have copper and chloride, which is the components of copper chloride, and with carbon electrodes, which are inert, the species that could be oxidized at the anode were chloride and water, based on the concentration of chloride. But with copper electrode, it is also possible that the oxidation can involve the copper metal of the electrode. So at the anode, possible reactions are chloride oxidized, water oxidized, copper, which is the copper electrode itself, can also be oxidized. The highest number or the highest value is the one for copper. So based on the negative standard electropotential value, the oxidation of copper will be preferred as it has the higher negative standard electropotential value. At the cathode, we discussed that before, the value of copper is higher than the value of water, so the reduction will happen to the copper ion rather than water molecule. And the copper metal will be discharged at the cathode. Reactions that occur with low copper electrodes, So here reduction at cathode, copper ion plus 2 electrons give copper metal, and oxidation at anode, copper metal will give copper ion plus 2 electrons. Observations: if it is stained and old, the copper cathode will change to a pink brown color as fresh copper is deposited on it, and the color of the solution will remain constant. Why constant? Because each blue copper ion reduced to copper metal at the cathode is replaced by copper ion formed at the anode, because the copper electrode will be oxidized into copper ion, so the color will stay the same. The copper anode will start disintegrating as the copper metal it is made of is oxidized to copper ions. So this is why the copper anode will start to disintegrate. Write an equation for a reaction that occurs during the electrolysis of sodium chloride aqueous that doesn't occur during the electrolysis of sodium chloride. Molten sodium chloride, which is sodium chloride liquid, ions present, sodium ion and chloride anion here, sodium cation and chloride anion. Reduction at cathode, sodium plus ion plus electron gives sodium metal, and oxidation of at anode, chloride ions will give chlorine plus 2 electrons. But aqueous sodium chloride, so we have sodium ion and chloride anion, but at the anode possible reactions are, so we said that chloride can be oxidized into chlorine, but also water molecule can be oxidized into oxygen and 4H plus. So as we discussed before, we need to compare the standard electrode potential of both, and the higher one is more preferentially to be oxidized. So the oxidation of water will be preferred as it has the higher standard electrode potential value. At the cathode, possible reduction reactions are sodium can be oxidized into sodium metal and water oxidized into hydrogen gas plus 2 hydroxide ion. But the value is higher for water, so it can be reduced more preferably than reduction of sodium. And hydrogen gas will be discharged at the cathode. So at any concentration of sodium chloride, the reaction at the cathode for aqueous sodium chloride is different to the reactions that occur at the cathode with molten sodium chloride, because the value is too big. So at the cathode, always, whatever the concentration of sodium chloride, always water will be reduced rather than sodium. Sodium will not be reduced. And this will be the reduction equation. However, at low sodium chloride aqueous concentrations, the reaction at the anode is also different for aqueous sodium chloride than with molten sodium chloride. Water is preferentially oxidized in the aqueous solution to form oxygen gas. So water will give 4H plus oxygen plus 4 electrons. But at high concentration, the story is different, because at high concentration of sodium chloride, the same reaction occur at the anode as with molten sodium chloride, which is chloride give chlorine gas plus 2 electrons.